This lesson will focus on determining whether a linear equation will have one solution, no solution, or all real number solutions. So there are three possible cases that can result when solving linear equations. The first, which you'll see most often when you solve an equation, is that you will find one solution for that variable value. You'll find one single solution, and as you're solving, you'll end with something like x equals 10. You will get a single solution for x that makes the equation true, and that will be your one solution for that linear equation. However, there are actually two other cases that we need to be aware of. One of them is that we will actually get no solution, and this does happen. There are situations where the equation that has been created is not possible. You cannot get a solution for x that will make that equation true no matter how hard you try. And then the third possible case is that you'll actually find an equation where all real numbers, or every number, is a solution. So these are the three cases that you will see. You'll see instances where you get one single solution for an answer, you'll get instances where you have no solution, and then you'll have instances where every real number, all real numbers, are a solution to that particular problem. So we're going to talk through on the next few slides how we can determine, do we have one solution, no solution, or all real number solutions to our linear equation. So the best way to really see these in action and to be able to determine one solution, no solution, or all real number solutions is to just dive in and start examples and see what happens. So we're just going to dive in and start this problem and see what results at the very, very end. So hopefully your brain is telling you that you need to always start by distributing. So we're going to start there by getting rid of the parentheses, by distributing out the 9. So here we have 9z plus 27 on the left-hand side. And then from here, your next step is you need to combine like terms on each side, which if you look, no like terms to combine here, no like terms to combine here, so they're completely simplified on each side. And then from here, we need to start getting all of the variables together on one side of the equation. So I'm going to move this 9z to the other side of the equation by adding a negative 9z to each side. And as I do that, this becomes 0, so I'm going to just write 0z plus 12 equals 0z again plus 27. And I know my math well enough to know that 0 times any number is just 0, so that's really nothing there. And what happens is I'm left with 12 equals 27. So as I started solving this linear equation, I eventually had all my variables undo each other. So there's no more variables left. If you look here, no variables. And I'm left with this statement. And right here I'm left with the statement of 12 equals 27. And any mathematician knows that 12 equals 27 is a false statement. That is something that is not true. So if you are solving along, and you end up with no variables and just some false statement, this is a situation that has no solution. And if you look back up here, we can actually trace the y if we go back to this second step right here. So what this really said was it said 9z plus 12 equals 9z plus 27. Well, the tricky part here is that 9z and 9z, these are going to have the same value because z is going to have the same value. So this is saying take 9z and add 12 to it, and that will be the same thing as taking 9z and adding 27 to it. The math there just doesn't make sense. So you actually could have made a judgment call back up here in step 2, but if you didn't pick up on that and you need to go all the way to this point where you have no variables and a false statement to determine that it's no solution, that is a-okay. So just being able to explain why what you're seeing on your problem and your work tells you that you have a case where the equation will have no solution. All right, so same thing here. We're just going to dive in and start the problem and see what happens. So I'm going to start here by utilizing keep, change, change, keep, change, change, and then I'm going to distribute. So here I have 3 plus negative 4a is equal to 5a plus negative 15. So then from here, now that I have all my distributive properties done, I'm going to make sure I don't have any like terms on the same side of the equation. So if I look at the right-hand side, I don't see any. If I look at the left-hand side, I don't see any. So I know that each side of the equation is fully simplified. Then my goal is to start getting all of the variables together on the same side of the equation. So what I'm going to do is I'm going to move this 5a here by adding a negative 5a to each side of the equation. So as I do that, I find that I have 3 plus negative 9a is equal to negative 15. And then I'm going to undo that 3, add negative 3 to each side. So these will cancel out. And then I'm left with negative 9a is equal to a negative 18. Divide both sides by negative 9. And I find that a is equal to 2. And since in this situation, unlike the previous slide where my variables disappeared and I was left with a false statement, here I actually got an answer. So if you actually get an answer, this is a situation where you have one singular solution. So you're able to figure that out by solving and actually finding a solution. That tells you that that particular problem has one solution. All right, so again, we're going to dive in, start solving, and see what happens. So I'm going to start by utilizing the distributive property here. So I have 2x plus 10 is equal to 2 times x is 2 plus 2 times 5 is 10. Then what I'm going to do next is I'm going to start getting all of those variables together. So I'm going to add a negative 2x to each side. As I do that, on the left-hand side, I end up with 0x plus 10 is equal to 0x plus 10, which I know that 0 times x is 0, so those are a little repetitive. So I just have 10 is equal to 10. And what I'm noticing here is that as I solved, I have no variables left. But unlike a couple slides ago, 10 equals 10 is a true statement. So if you have no variables left, but you're left with a true statement, what this is telling you is that all real numbers are solutions. So you have all real number solutions to this particular problem. And the reason that this is true stems all the way back up here to, again, this second step. So here you can see that you have 2x plus 10 equals 2x plus 10. And realistically, if you think about it, no matter what x is, say x is equal to 5, it would be 2 times 5 plus 10 equals 2 times 5 plus 10. That's true. Say we changed 5, so we're changing 5, and we're going to change it to 4, or let's change it to negative 4. 2 times negative 4 plus 10 is the same as 2 times negative 4 plus 10. Because both sides of these equations are identical, it doesn't matter what we pick for x. Ultimately, we can pick any real number that we want for x, and that equation will be true. So what you're looking for, if you have no variables and a true statement at the bottom, then you have an all real number solution situation. So just to recap those last few slides, we will have 3 cases when we're solving linear equations. One case we'll have is where we have one singular solution. And what happens when we get one solution is we get one answer set equal to a variable. So you'll have a situation like x equals 4. That's the first situation that you will see. Second situation that you'll see is a situation where you get no solution. And what will happen here is your variables will undo each other and you'll be left with no variables in your equation. And you'll be left with a false statement. So you'll be left with something like 10 equals 17. Something will happen along the way where your variables will undo each other. You're left with a false statement. And then finally, our last option is that we have all real number solutions. And what will happen here is that you'll have no variables, just like your no solution situation. Your variables will undo each other at some point and they will be gone, but you'll be left with a true statement. So something like 17 is equal to 17, something that is true, telling you that all real numbers will work in that equation and will make that equation true.